Welcome to Lesson 3, Multiplying Polynomials Review. So at this point, we have gone over adding and subtracting polynomials, which means adding and subtracting like terms. And for like terms, we have to have the same variable with the same exponent. Or we have to have numbers, just plain numbers that can be added or subtracted. When it comes to multiplying polynomials, however, and really we're going to kind of focus on monomials here, you still have to have the same variable, but you do not have to have the same exponent. So the rule, multiplying powers with the same base. The rule is you add the exponents. Now, the base is the variable in many cases. So if we have a to the n times a to the m, that would be a to the n plus m. A would be the base. What a lot of times people forget is that this works for numbers as well. So for example, 3 squared times 3 to the fourth. You don't make that 9. Okay, if you look back at a to the n times a to the m, we kept the base a. The same thing happens with numbers. You're still going to have a base of 3, but the exponent will now be 2 plus 4, which is 6. Okay, so we have some examples here off to the side. Number 1, x squared times x cubed. Well, that's pretty simple. That's going to be x to the fifth. For number 2, now we're multiplying monomials. We were in number 1 as well, but we have more multiplication going on. So you want to look for coefficients. They always get multiplied. So 2 times 3 is 6. We put the x's together to make x to the 7th because we add the exponents. And there's nothing to go with the y, so that just stays as it is. Okay. All right, then we have powers of products. That simply means that if you have a product, so let's say A times B, and you put that to a power, the entire thing, let's say to the n, okay? What's going to happen is that A will now get that exponent of n, and B will get that exponent of n. Basically, you're like distributing the exponent. So for number 3, we have 2x, a product, to the fourth. Well, that's going to become 2 to the fourth times x to the fourth. And then usually when we have, numbers with a power, we actually go ahead and simplify that. 2 to the fourth is 16. So we end up with 16x to the fourth. Now, what if your variable or number already has an exponent on it other than 1, as in the case of number 4? Well, this is what we call power of powers. So if we have a to the n, and again, a can be a variable or a number, it does not matter, and we put that to the m power, this is where we actually multiply the exponents. So we get a to the n times m. It's very easy to confuse this rule with our first rule, where we add the exponents, okay? At this point, you've had algebra for a long time. You would have done some of this in geometry as well. It's really just a rule you have to remember. Another way, though, to remember it, well, like if we look at number 4, the rule says we would multiply. So we would get y to the 15th. Okay. Another way to kind of think of this, though, is that you have y cubed 5 times. So if you think of it as multiplying out y cubed 5 times, Now the rule would kick in where we add the exponents. And sure enough, if we add all these exponents, we get 15. Okay. And just because there's not an example here, I want to just fill in one more example. Let's say you had 2 squared x to the 7th cubed. Okay. Actually, I'm not going to have that 2 squared. I'm just going to have 2. A lot of times people forget there is an exponent on that 2. It's a 1. So we would apply our rule and we would multiply the exponents. Don't worry about changing the 2. Treat it like any other base. So we would get 2 to the 3rd, 1 times 3, times x to the 21st, 7 times 3. Now you could go ahead and put that in your calculator, and 2 to the 3rd is x, or it's 8, sorry. Okay, now we review multiplying binomials and polynomials. This is something you would have spent a lot of time on in Algebra 1. The term FOIL might come to mind. If not, that's fine. But when you multiply binomials, we'll start with that, like number 5, you have to remember that you are using the distributive property. And you don't have to write it out like this, but this is what's happening. So for number 5, we are distributing the x to x minus 3. Then we are distributing the 4 to x minus 3. Whenever you multiply 2 binomials, you should always end up multiplying 4 times, and you should end up with 4 terms. What you can do after that all depends on the binomials. You know, a lot of times you can combine like terms. So now when we distribute, we get x squared minus 3x. So I distribute the x, and now I distribute the 4. So plus 4x minus 12. And as is often the case with these types of binomials, the 2 middle terms are like terms. So negative 3x plus 4x is positive 1x, and then minus 12. Now I mentioned the term FOIL, and for those of you that are familiar with that, FOIL is an acronym we use to help you remember, first of all, that you're multiplying 4 times and what you're multiplying. Okay, sorry about that. So F stands for firsts, so that would be x times x. O stands for outers, so that would be x times negative 3. I stands for inner, so 4 times x. And L stands for last, 4 times negative 3. You get the same exact thing just by using an acronym, okay? I just prefer saying you're distributing twice. Again, you don't have to write out this step, but if you're somebody that tends to forget to do all the multiplication, I would highly recommend it. Okay, now for number 6. You haven't been in my classroom yet, and actually I haven't put them up, but I have these posters that, well, they're supposed to be funny, but they address this situation right here. A very common mistake that people make with this situation is they'll say, oh, it's x squared plus 49. I square the x and I square the 7. You have to be really careful. This example, number 6, is not like number 3 up here. Number 3, yes, we put the 2 to the 4th power and the x to the 4th power. We could do that because it was multiplication between them. You cannot do that with addition or subtraction. So your best bet is to write this out as what it is. It's x plus 7 times x plus 7. And now do your distributive property. So I'm not going to write it out again, but I'll distribute the x first. So x times x squared, x times 7, 7x. Then I'll distribute the 7. 7 times x, 7x. 7 times 7, 49. Once again, we can combine the two middle terms to give us 14x. Now, there is kind of a shortcut when you are squaring a binomial, but I'm not going to go over that right now because a lot of times people don't remember the shortcut anyway. I would just recommend that you write it out. All right, and then lastly, we have a binomial times a trinomial. Well, if you really just try to think of this as using your distributive property, there's actually no difference between number 7 and numbers 5 and 6. The only difference is that we have a third term that we have to distribute to. Other than that, it's exactly the same. So I am going to distribute my y to all three. So that gives me 2y cubed plus y squared minus 8y. Then I'm going to distribute the -6 to all three. So negative 12y squared minus 6y plus 48. Again, we're going to have like terms, so you just want to be careful as you go through. We have 2y cubed, and then we have positive y squared minus 12y squared. So that'll be minus 11y squared, minus or negative 8y minus 6y will be negative or minus 14y, and then on the end, plus 48. Now, something else you can do, and maybe you were shown this in Algebra 1, is to do a box. I apologize for that noise. It's outside. Where you have your y and your -6 here. And then along the top, we have 2y squared, y, and -8. So kind of like a multiplication table. And now you would multiply that way. And what will happen is if you do it this way, you get the exact same terms that I had up here. They're just in a box, in a rectangle, and now you would combine them. That'll work also for problems like 5 and 6 as well. So again, you may have been shown that, and if that helps you, go for it. So here I might put x and 4 here, x and -3 here, and again, do a times table, fill it in, and then you get your like terms.